Hi, welcome to question 9 of the 2025 Leaving Cert Ordinary Level Paper 2. This question is on kind of area volume measurement. The first part here, part 1 and 2 are marked together. Again, they're worth a 15 mark on the D scale. So we'll read through and be careful to read these carefully. And this particular one here is involving construction. So Clodagh is making a wooden table for her woodwork class. The triangle ABC below is a scale diagram of the tabletop. So we see the table itself and they're looking downwards on the kind of weird triangular shaped tabletop. The tabletop is supported by one leg attached to the centroid, which is the center of that table, to give balance, as shown in the diagram on the right. Part 1 says, on the diagram below, construct the midpoint of the side AB, label this point D. If using measurements and calculations, show all calculations clearly. And there's probably a few methods for this, but the classic one is that this is a construction. I'm going to try to use my pen here. We're trying to work on AB, which is this line here. Okay. And if you get your compass point, and I appreciate you can't see this, but if you put your compass point on B and bring it further than the center, the midpoint of that line, and draw an arc. Okay. Now we're using the same compass length. You put it on A, the compass point, and draw an arc which will be more than halfway. Now those two arcs intersect at 2 points, and we draw a line through them with a ruler. Now I'm not using a ruler, but whatever. Okay, that's not too bad. And that's your midpoint of that line. Now I think I have a kind of infographic showing that here, but it's not the same as what I just did, okay, in terms of construction. Make sure you show all your construction lines, and then that's going to be part 1, correct? Okay. Now the marking scheme does state that you get low partial for work of merit in 1, a relevant work on diagram or a measurement. Maybe if you measured 15 or 7.5 centimeters, so like that must be 15 centimeters, half it is 7.5. You're making an effort at finding the midpoint. Okay. Now, part 2 says, hence construct the centroid of the triangle ABC, label this point O. Now, actually, I realize I never actually labeled that D. I should have put a label of D because they do say it and there'll be a penalty for not. But the centroid is effectively the same thing. So you'll have the line here from, I'll redo it, from AB, and you brought the line through it. Yeah, I was doing really well the first time. Let's try to do that. Now that would be D. Okay, you're going to do the same thing with either line. So let's take the AC, it's more clear. So again, you put your compass point on C, create an arc larger than halfway, put your compass point on A, draw an arc greater than halfway, and then join those two lines. Now you can do the third side as well. That should hit this point in the middle. And I appreciate there's lots of mess there. That point here where the two lines meet, that's the point O. Now, I appreciate that's not the best diagram in the world. I'm doing it freehand. It would end up looking like this. You've created the midpoint of these two. That's what we did initially. Now, in the marking scheme, they've done the midpoint of these 2 points here. Now, the one thing I neglected to say with this particular diagram here, and I apologize for this, is from that point here, I should have brought it to here. And from this point here, I should have brought it like up to here. That's where those lines intersect. So apologies for that. Worth looking up a video on YouTube just to clarify that with a better diagram. I just put in how to construct a centroid. Got some lovely videos that will express it better than I can on this particular tablet thing here. Right, so that's it. Now, B part 2 is a 10 marker as well, okay, on the D scale. It says Finn is making a pair of triangular tables, one bigger than the other. And we see the two tables here, one is obviously smaller. The bigger tabletop is an enlargement of the smaller tabletop. The scale factor of the enlargement is K. And there's a few formulas here that are not given in the maths tables. I just double checked a minute ago and I couldn't find them, even though I'm 99% sure that I didn't, you know. But anyway, part 1 says the longest side of the bigger tabletop is 45 centimeters. The longest side of the smaller tabletop is 36 centimeters. And if we're comparing the same two sides, they should be increasing in the scale factor. It'd be a way of finding the scale factor. Now they say show that the scale factor K is equal to 1.25. So these formulas are ones you'll have to memorize. Okay, this is the formula. So K is equal to the length of the longest side of the big table divided by the length of the longest side of the smaller table, or the length of the bigger divided by the length of the smaller. That should give K. Now when I put the numbers in, 45 over 36, that simplifies down to 5 over 4, which we turn decimal is 1.25. That's it. Now, part 1 and 2 are marked together. So the part 2 here says the shortest side of the smaller table is 25.5. Work out the length of the shortest side of the bigger table, correct to 1 decimal place. Now we use the same formula, but we're comparing the shortest side with the shortest side of the two tables. So we have the scale factor of 1.25, okay? We have the length of the shorter side, which is the one that goes on bottom. So we end up with this equation here. 1.25 is equal to, let's just say X or L or whatever, unknown divided by 25.5. We can simplify that by multiplying across the 25.5. It was divided on the left, so it'll be multiplied on the right. Sorry, divided on the right, multiplied on the left. That's a calculation we can throw through the calculator. I got 31.875, but they do say correct to 1 decimal place. The 7 is what matters. 7 is greater than 5, so the number before it rounds up by 1 to give 31.9. Always include units. In this case, the units are centimeters. That's part 2. Now, part 3 says this is a different formula here. The area of the bigger tabletop is 724 centimeters squared. Area units are always squared. Use K is equal to 1.25 to find the area of the smaller tabletop. Give your answer correct to the nearest centimeter squared. Okay. Now this formula is kind of different. Okay, it's K squared is equal to the area of the bigger table divided by the area of the smaller. Now we know the area of the bigger, we know K, so we can fill those numbers in, and we end up with only one unknown. Even though I'm using a word to describe it, you could just call that X if you want it. Okay. Now this is a bit trickier algebra. I need X to be on the top on its own. Okay, just so it's currently down here at the bottom if I'm calling this X. Now you can bring the area across. Okay, it was divided on the right, it'll be multiplied on the left. And at the same time, this area that moved across here is multiplied by the 1.25. So I'm going to bring that across the equal. It was multiplied in this imaginary scenario on the left. It'll be divided on the right. Now there's two different algebra things going on there. It's the same rule or same idea. So you may need to do that out like step by step. Just the notes here don't kind of lend to that. When I do this calculation on the right hand side, I got 463.36, but they asked this to be rounded to the nearest centimeter squared. The 3 here is what matters. It means the next number doesn't change. So it's 463 centimeters squared. Now, kind of next question here gets a bit tricky. It's a 10 marker just for part 1. We'll read through it, but if you can understand what's going on here, it can try to help. And just knowing that a full circle has 360 degrees, but you can have like a half a circle, a quarter of a circle, or you can have 250 over 360 of a circle. Okay, and that's maybe the hint here. It doesn't have to be the full circle. And if you're using an area formula or a perimeter formula, a sort of circumference formula, you have to adjust it by the amount you're talking about. And that's why you multiply it by that fraction. Now, a table used for a cookery demonstration is in the shape of a sector of a circle, okay, with a radius of 160 centimeters. So this is a sector, okay. And then the table has a teacher section here, a demonstration section, and a work section. So kind of an outer lip. That's where you work. You display your stuff here, and the teacher can be in helping out, doing whatever the teacher does. So hopefully that image there makes sense. Take a bit of time to kind of think it through and visualize it. It'll really, really help, in my opinion. So part 1 says the shaded area is the work section. It has a width of 40 centimeters, and we see that indicated here. Work out the area of the workstation. Give your answer correct to the nearest centimeter squared. Okay. So in a way, if you think of this as being 2 circles with a chunk cut out, if I get the area of the big circle, take away the area of the inner circle, I would have the area of the entire shape here, okay? And then I'm just going, right, I'm going to take out this section, or I'm only going to talk about this bigger section, and that's what the notes will do, okay? So the area of the large circle is pi r squared, okay? We know the radius of the large circle is 160, okay? I swap them in, put it through the calculator. I'm going to leave it in pi form because I don't want to mess with decimals and rounding. So the area of the big, huge circle is 25,600 pi centimeters squared. Now, if I move on then and think of the smaller circle, the little one in here, okay, that's the same, pi r squared, okay. But I don't know the radius, but I do know that it's 160. Take away this 40. What's left is, 120, okay. So now that I know what the radius of the smaller circle is, I can put that through the area formula, and I got an answer of 14,400 pi centimeters squared. Now, the difference in them is the area of the total work area, like if it's going through the teacher section, okay? And I got 11,200 pi, but there is no work section in the teacher section, like they're standing in there, okay? So I only need to worry about this 250 degrees of the full 360. So I'm multiplying my full work area by that fraction, which will reduce it. I got an answer of 24,434.6. They asked me to round that to my nearest centimeter squared. The 6 here is what matters. It rounds the next number up by 1 to give me the 24,435 centimeters squared. So tricky enough question. There's lots going on there. None of the calculations are specifically like crazy hard. It's just to know what's going on. Now, practice makes perfect. These kind of questions, once you see them and you get the hang of them, they're really obvious. But that's, not the situation for everybody. Okay. Now, it then said each participant attending the demonstration needs at least 60 centimeters along the outer circumference of the work section of the table to carry out the food preparation. Find the maximum number of participants who can attend the demonstration. So you think about it, this work area, everybody gets the little section, like 60 centimeters. How many of them are in there? Now, to be able to figure that out, we need to know the length around the big circle, and we need to know what bit of that is work section, because again, there's no work section here. So it'll be whatever the length of this big circle is, it'll be what's 250 out of 360th of it. So almost, like, just say 3/4 for simplicity. So I'm going to look at finding the length or the circumference around the full circle, and that's given by the formula 2 pi r. We know that the radius of the big circle, okay, is 160, okay? So it's 2 pi times 160 by the amount of the table we're talking about, this section here, which is only 250 out of the 360. Now that's a calculator job. Put it through. I got 693.13, okay? Now there's no such thing as 0.13 of a person, and if so we generally, if a number like that, we'd have to worry, take away the fraction. But that's the total work area. Each person gets 60. So the question I'm asking there is, how many 60s in 693 or 98.13? Now I got 11.6, and this is where we're more specifically concerning with the decimal. If you put a 12th person in there, they wouldn't have enough space. So it rounds down to the 11. You can fit 11 people around that table, okay? You can't fit 12, okay? Because 0.6 of a person is not a person. That's it, okay? Now, that's tricky enough in a way, but always be trying to get the low partial or the mid partial. But if you even just found the length around the full circle and stopped, you'd get the low partial, okay? Even in questions that maybe are tricky for you at that particular moment in time, if you're getting the low partials, that's going to really be beneficial to you. Now, that's the end of question 9. As always, if you want a copy of these notes, send an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.